Okay, so today's chapter 4 is going to be about integers, fractions, decimal, and percentages. Integers, fractions, decimals, and percentages. Now, so we'll be talking about fractions first because you already know what integers are. So, first things first, fraction. Fraction is essentially two numbers, A and B, that is already in simplest form. That means you can't cross them out, or it cannot be broken into smaller parts. Fraction is essentially the ratio of two integers, A, B, and A, B are, well, they're integers, right? And B cannot be equal to 0. For example, 2 over 3, 8 over 7, 12 over 61. These are called fractions. The A portion right here is called the numerator, and this is called denominator. And there are many types of fractions. There's this thing called proper fraction and improper fraction. A proper fraction is a fraction that has numerator less than its denominator. For example, 2 over 3 is a proper fraction. 12 over 61 is a proper fraction. 8 over 7 is an improper fraction because the numerator here, 8, numerator 8 is more than 7. So 8 over 7. Another example of improper fractions would be 3 over 9. And 3 over 9 can be written as 1 over 3, simplifying it. They are both still fractions. This is still fraction. This is still fraction. It's just the same thing. They're the same thing. It's just a smaller part of it, like reduced form. Now, and there's also this thing called mixed number. Mixed number is essentially a number, an integer with the fraction. For example, 4 and 1 over 5 is actually 4 plus 1 over 5. This is just a shorthand notation for the sake of simplicity. And let's say in a mixed number, the second portion here, the fraction one, is always a proper fraction because, let's say I will write it as 6 over 5, right? This is essentially 5 plus 6 over 5, and 6 over 5 is equal to 1 plus 1 over 5. Because this is 6 equal parts, right? Like say 6, 4, 5, 6, right? But the space here, the 5 here, it's like it's more than needed. So this will be taken by that, this will be taken 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 by that, and it would become, so there'll be 6 but only 5 places, so it will become, this one left out would be 1/5 plus by 5/5, because these are the 5 places taken, right here, and the missing part is right here, 1, and 5/5 is equal to 1. That's why it's 1/5 plus 1, or right here, 1/5 plus by 1. And that's the case. 6/5 is 1 plus 1/5. So this plus this plus this becomes 6 plus 1/5, and the shorthand notation is 6 1/5. Okay, these are called mixed numbers. Now, to find a fraction, let's say find a fraction, 1/5 can be written as, since it's divided into 5 equal parts, right? 1 is here, 5 equal parts, but only one place has been taken, just the one here. So it can also be written as a percentage, and the percentage form is equal to 0.220, because in terms of percentage, it will be with respect to 100%. So they'll consider this 100%. Right. 100%, then this only takes 101 out of the 5 places, then it only takes up 20%, because 20 plus 20 plus 20 plus 20 plus 20 equals to 100. And this is called decimal form. Decimal form. Multiplying and dividing fractions. Oh, and also addition and subtraction of fractions. First, we'll be talking about addition and subtraction of fractions. So let's say have a fraction a over b, and it's plus by c over d. Then you want to add it. This is how you do it. You have to make the denominator the same. So a here, b here. You times a and b by d. Okay. C and d over here. You times it by b on both numerator and denominator. Now it becomes AD plus by CD over BD. That's how you add it. And the explanation for it is this. Let's say, for example, you have 2 over 3 is plus by 4 over 5, right? Then this will become 2 times by 5, 2 multiplied by 5 over 3 multiplied by 5 plus by 4 multiplied by 3 and 5 multiplied by 3, which becomes 10 over 15 plus by 12 over 15, that becomes 22 over 15. Let's say the expression is here. Let's say out of 3 of them, this, let's say you have a box and it's divided into 3 portions. And another box, which is of equal size, but for this one here, it is divided into 5. So 5 of them. So this is 4 over 5. Over here, it's 2 over 3. Since we can't really add 2 plus, we can't really do this 3 plus 5 for these two. That does not work. It does not equal to 6 over 8. It does not really make sense. We essentially adding the contents inside this one. You're not adding the space or the box. We're not adding 2 boxes together. We are essentially adding the contents inside. Now, since, as you can see, the length, the thickness of these are different, right? So it doesn't really make sense to add 2 and 4 because they're of different size. So we have to make them the same. When we convert it to 10 over 15, it's the same exact box, but we are dividing it into equal length, right here. This becomes this, this becomes this. Now we can add them together because they're of equal sizes. Now this becomes 12 over 15. So there, we got 12 pieces here, and over here we got 10 pieces of equal length. So we can add them up now, and it becomes 22 over 15. There are only 15 places. So the same box right here. The places, there are only 15 of them, but all of them has been taken up already. So 15, and then plus by another 7 pieces. This can also be written as 1 plus 7 over 15, because 1 is here, like 1 complete whole. It's added by the 7 pieces left. It's an extra, not enough space. And that logic would also work for subtraction. When you want to subtract things, we just do the same process. We change this to negative instead. You essentially have to make denominator the same, so it'll be fair to make them of the same thickness. That's for addition and subtraction. Now for multiplication and division. Multiplication. Let's say I have A over B and it's multiplied by C over D. You essentially multiply the numerator with the numerator and denominator with another denominator. A times C plus by b times d, right? You can write it as AC over BD. Example, 2 over 5 plus 2 over 5 times by 6 over 7 would become 2 times 6 over 5 times 7. And that becomes 12 over 35 right there. That's for multiplication. And the explanation is here. Same logic, let's say a box of 5 equal spaces. Two of them has been taken. 2 over 5. Now another box right here. But this time it's divided to 7. 6 of them is taken. 6 over 7. When you multiply them, you're essentially saying how many of the green pieces, let's say I have 6 here, multiply by the 2 orange pieces. So yeah, so 6 times 2, at 12. But then you also want to multiply the box. So it becomes 5 times 7, which is equal to 35. Basically the spaces of the boxes. Let's say then you would have boxes of 35 spaces, which 12 of them, 12 will be taken. That is essentially the logic. Now for division, have A over B, let's divide by C over D, then it becomes A over B times by D over C. So it'll be A times D over B times C. You can essentially turn the division into a multiplication, and you perform the same logic as before for multiplication. The explanation here is this. Say 2 over 3 is divided by 6 over 7. As we already know that 2 over 3 divided by 6 over 7 can be written as 2 over 3 and the entire thing divided by 6 over 7, right? And it's basically asking 6 over 7 times by what number, you get 2 over 3, right? So with this logic, we could multiply both sides by 7 right here, and this would cancel out that one, becomes 1. So 2 over 3 times by 7, and then I could times both sides by 1 over 6. This would be cancelled out to make 1. So that box would be equal to 2 over 3 times by 7 over 6. Or another way to think about it is this. 2 over 3 times 6 over 7 times by something, and you get 2 over 3, right? You could think of it as, well, since it has to be multiplied by something. It has to be multiplied by something, right? And you have to get 2 over 3. 7 has to go away first. So I'm certain that because there's no 7 here, so whatever is here must have 7 in the numerator. Must have 7 in the numerator. And it must also have it must have 7 in the numerator, so we'll cancel that one. But it must also have 6 in the denominator to cancel with that one to make 1. But then this would equal to 1, but that's not equal to 2 or 3, right? So we must also multiply by something. 2 over 3, because it'll become 2 over 3. Now that makes sense. So that box is essentially this thing, and I could write it as 2 over 3 times by 7 over 6, which is the same as this one here. Switch it. The reason you switch it, the C over D becomes D over C is essentially to cancel out with that one to make 1 first. And to make it similar to that one, we multiply it by A over B. That would be for division. Now, since we know how to do addition, subtraction, multiplication, and division of fractions, we'll move on to the next one, which is decimals. And then after decimal, we will go to percentages. Decimal and percentages are somewhat similar in a way. The only difference is that percentages is just written with relative to 100. Like everything is by 100, and it's written relative to that. Now, whereas decimals is something that's written at the base of 10, which is decimals, right? It's written at the base of 10. For example, 0.5, 0.8, 0.9, 0.9, right? That's also decimal. Or 2.3, that is also decimal, is essentially 2 plus by 0.3. And there are essentially 2 types of decimal, reoccurring and reoccurring decimal, and terminal or terminate decimal, which means that it stops. So we'll be talking about reoccurring decimals first. Terminate decimals. So reoccurring and terminate. You might have seen reoccurring from time to time. For example, 0.22222 and so on, keeps repeating. 0.77777, so on. 0.77777, 689, 689, 689, and so on. This 3 parts repeats. And the shorthand notation for it, it's 0.2 with a dash on top. Should be 0.7 with a dash on top, and it should be 0.689 with a dash on top. Or it could also be written as 0.689, 2 dots represent here, representing the beginning and the ending. And these 2 dots would be helpful when you have, let's say, 0.789694, 789694, and this keeps repeating, right? So you could put it as 7899694 with 2 dots here. I could use one long line. That would be recurring decimals. Recurring decimals can be, all decimals can be written as a fraction. So 0.2 is essentially 2 over 9. 7 is 0.7, so on is 7 over 9, right? And the thing that's repeat, this is, well, I haven't plugged into a calculator yet to confirm, but it's probably 689 over 9, but maybe not. I don't think so. Have to confirm later. But there's a way to convert this into a fraction. So don't confuse the terminate one. It's here. Don't confuse 0.2 with 0.222. They're not the same thing. 0.2 is 2 over 10 or 1 over 5, but 0.222 is 2 over 9. There's a big difference. They're not the same thing. Now, let's say that you were given 0.44444, right? That it repeats, and you want to convert it into a fraction. So you have 0.4444, and so on. But you want to convert it into a fraction. The way to do it is this. So let's say that x is equal to 0.4444. Let's say that's a number. X is equal to that. Now, 10x would be equal to 4.4444, right? And so on. What I could do is, notice that this right here, this here is the same as that, but this, the only difference is that that is equal to 4 plus by 0.4444, and so on. It's just a 4 added to it, right? Now, what I could do is, since I already know that x is equal to that, I could subtract x from both the sides. Now, this would become 9x, and this would become 4, right? Because x is 0.4444. And since it's equal to 4.4444, right? X I could find as x equal to 4 over 9. And since we already defined what x is, this must also be equal to 4 over 9. It is actually very simple. This is how you convert from recurring to yes, you can go to the toilet, don't worry. Now, since we know already how to convert 0.444 into a recurring, into a fraction, recurring to a fraction. Now we should work with the one that does not only have one number repeating. For example, 0.31, 31, or I could write it as 0.31. So I could use the same logic. X is equal to 0.313131 repeating, right? And 10x is equal to 3313131 repeating. And then I could divide both sides by x right here, same, right? And when I subtract both sides by x, this would become 3, and the other side will become 9x, and x equal to 3, and x is equal to oops, sorry, I made a mistake here. My bad. It's not 3/9, because 3/9 is 1/3. My bad. Okay. The number is wrong in the first place. Okay, so 0.0313131, right? I let x be 0.0313131, and so on. And I multiply both sides by 100. So this would become 3.1313113, and so on. I could subtract x from both sides. Subtract x from both sides. Since x is this here, so this will be taken away. Thus, it will become 3.1, and 99x by 3.1. I could times both sides by 100 to make it into an integer. Times by 100. Times it by 10. Times it by 10. This would become 31, and this would be 990 times x. So x is equal to 31/990, and since x, we define that x is this, thus this must also equal to that. Go with example 3. Now with 3 repeating numbers from here, 0.89 to 8.89. So 0.689, 689, right? Let it equal to x, and I times it by 1000. So 1000 times x would be equal to 689.689,689, so on, repeating. I subtract x for both sides, because x is that. This would be taken away, and this would become 999 times by x, 999 times by x, which would equal to 689. And that x is equal to 689 divided by 999. That will be example 3. And as you can see that it is somewhat similar, right? It's divided by 999, or it's divided by 9, or one repeating number. Or one repeating number. If it's two repeating number, then it's divided by 299, and then there'll be 0 from certain cases. Okay. Let's go with another one, final example. Two 2.0406 repeating, just so only 406 repeating. But since we already know that 2 points, this is essentially 2 plus 0.0406, we could use the same logic to apply this one. So let x be 0.0406, and then when I multiply both sides by 1000, multiply both sides by 1000, 1000x is equal to 4 0 6 4 0 6, and I could use same logics, subtract both sides by this amount, right? Subtract by x, put x here, subtract by x, and here 0.0406 to be perfectly taken away, and it becomes 999x equal to 40.6. Times both sides by 10 again to make it into an integer, so it'll be 9999x over 406, and x is equal to 406 divided by 999. And that would conclude decimal conversion for recurring decimal. And for terminate decimal, which means that something that does not repeat, like 0.25, right? It terminates, it stops there, or 0.8976, or something that might seem to repeat but not really repeat, 0.8989896.5, something like this. It might seem to repeat, but it does not. Terminates, and these can be written in a fraction as well. This would be, since it's 0.5 out of whole, so it's 1 over 4, and you could convert it very easily. This you can write as 28976 over 1000, 10,000 over 10,000, and you could cross them out, try to simplify it, and the logic will also work with the rest. And that would conclude the chapter 4, percentage, decimals, and fractions.